All right. So just for this week, I just wanted you guys to keep in mind that today is the due date for your station lab energy transformation. The second one is your Flipgrid energy transformation demo. I have a sample video that I posted in the Flipgrid. And so what you guys just need to do is show your energy transformation that you see at home. So I had an example, a battery-powered fan. So from chemical, it turns into electric and then mechanical energy. So that's why the blades of the fan spins. So that's an example. You only need one, okay? Tomorrow, I will be posting the student choice project. I'll show that in a few. And discussion post today is a problem set. It's just a simple, the triangle formula. And this time we're gonna find for wave speed, frequency, and wavelength. And so that's that today. Tuesday, I will post what the project is. Wednesday, discussion post due. And you're going to continue working on that student choice project. Thursday, continue working, and then I will post a check-in progress of where you're at in your student project. And then Friday, just the quizzes and continue on with the project. So there's no lab station this week. It's just going to be you choosing what project you plan to do. Now, the project doesn't mean it's manipulative or anything like that. It can be of the following. So I'll show you guys now. All right. So this is the first two choice. So you are going to choose any of the following to show what you have learned about wave properties, which I will go through quickly today. And then, of course, the objective of the lesson, I'll show that to you, and you guys will be able to get that copy later on. How do matter and energy interact when waves are made? What are the three main types of mechanical waves and its properties? And you're going to show what you know about it depending on what you choose. So here are the first two choices. First, you can do a comic strip. So you're going to create a comic strip, show how the water particles move during a wave action. So like in the beach, for example, if you surf, you can use a comic strip to explain the motion of the waves and then its properties and then what you have learned about it in a comic strip way. Or you can do a poster or an infographic. So when you say infographic, you get a bunch of images online, you put them together and show the types of waves, properties of waves, some vocabulary words that relates to waves, which you'll see later on, particles of waves, and any other information you learned while researching waves. Okay, so that is your first two choice. The second part, there's two more, which is your news report or student choice. So news report is you're going to be in a star. So for those who wants to use the video, you can produce something, record yourself, do some research about an earthquake. So you're kind of like CNN, and you're going to research about earthquake waves, and you are going to relate that information with what you learn about the wave properties. So it's the seismic waves that you're going to talk about in a news report. Alternatively, which I think I did not show it here, you can use a slide presentation to talk about a research about waves. I will give you guys that info, like a PDF file of which one you want to choose, and then we're going to do that. Gavin, this is not due until next week on Monday. Just like the station lab, it's always due. A long assignment is always due the following Monday. Okay? So it doesn't need to be very grand because you guys have an exact information that you guys would want to choose later on. And then, of course, student choice, choose a presentation style you want that relate as long as your presentation has to do with the properties of waves. So you can research something that is a phenomenon about waves and all that, and then you present your idea however you want it. And you just have to let me know what it is exactly, just in case the choices that I gave you, it did not kind of like sit in with you and you're more comfortable doing something else. okay? As long as they are connected to our lesson. All right, so that being said, I'm gonna go through quickly about properties of waves. There are kind of like checkpoints that I want you to write your answer to, and you're going to type down your answer on the chat box or your paper, okay? So our objective for today is for us to, how do matter and energy interact when waves are generated? So waves, the waves in the beach, the waves that you might have seen on TV, seismic waves, and all that. So we're going to talk about two types of waves, which you'll need that in your project, and the properties of waves. So what are those parts of the waves? All right. So on your piece of paper or your notebook, you can also use the chat box to answer the following questions. So first off, how can you create waves? What materials will you need if you want to show and create waves? So that's our first. Where do waves travel? What was the source of energy for your wave? And after 2-3 minutes, okay, we'll answer. So we'll start first with the first one. How can you create a wave? So you can type your answer on the chat box, and I'll read it out loud so other people can, think about your answer, and they would also answer. All right, go ahead and answer. So I see Cameron said splash of water. You splash the water, you create waves. Sound creates wave. When you put force at something, it creates waves. Electrical wave or water wave, yes, that's correct. Anything else? Light emits waves. Now, what material do you need in order for you to create waves? Can it be anything? How about a rope? Yes, a rope. Underwater earthquake? Yes, that's right. So those are some of our ideas about waves. Now, even if we don't see them, especially for the light waves, they actually travel to an empty space. I think you can use anything. That's correct, Mary. You can either use a solid, a liquid, or a gas and create wave. Radio waves is another waves, and later on we'll find out what type of wave these are. And of course, the source of energy for your wave is, of course, if you apply a force, if there's a force around. All right, so pretty much you can just use your piece of paper, vocabulary. Later on, we're going to play Quizlet towards the end, so you can kind of like quickly jot down something as I explained before I move on to the next, and focus on the ones that are highlighted. All right, so let's discuss. Waves are disturbance that transfers energy, okay, from one place to another. So any disturbance that you do on something, that's waves. And remember that energy is the ability to do work. And an example is the energy carried by a wave. If you look at the picture, it can lift a large ship because of that disturbance. And that disturbance transfers that energy to the large ship, causing for it to move. So let me know if I'm being very fast, but just focus on this simple highlighted words. Waves, disturbance, transfers energy. All right, what causes waves? It is generated when the source of energy forces the matter in a medium. Okay, so that energy, when you apply energy to some medium, it can be solid, liquid, or gas. It causes that object to vibrate, and that vibration, which is called back and forth or up and down motion, of course, generates waves. So as you can see on the picture, when you just quickly dip your hands on the water, it creates a ripple, and that ripple is the waves itself. If you have a rope tied up to a tree, then you start moving the string or the rope tied up to a tree, it creates a back and forth or up and down movement, which is the vibration generated by the energy and the force that you apply. Now, there are two types of waves, but before we go to that, the mechanical waves, which has two types, can only travel through a medium. So the medium, it could be liquid, such as water. So the ocean waves travel through water. Sound waves travel through air, which is the gas. And of course, the wave can also travel along a rope. So that's your liquid, gas, and solid. And you call all these waves generated as your mechanical waves. Okay, Dean, you're talking about the type of waves in the ocean, the trestles. Is that what it is? Cool. All right. So another type of wave is called electromagnetic waves. Someone mentioned about light waves. So electromagnetic doesn't need any medium. It travels through an empty space or a vacuum space, okay, such as your X-ray, visible light, microwaves, radio, and ultraviolet rays. So they don't need a medium in order for it to travel. So these are all electromagnetic waves. Later on, we'll talk about that, electromagnetic waves in particular, next week. So that's electromagnetic wave. But today we're going to focus on mechanical waves only. And these are the waves that travel through a medium. We have transverse and we have longitudinal waves. So these are the two types of mechanical waves we're going to talk about. So letter A, if you look at the diagram, letter A is transverse, letter B is longitudinal. And we're going to differentiate both of them. All right? So before we start, let's take a look at the short demonstration of how these mechanical waves look like using a slinky. Describe the motion of the wave and type a response on the chat box. So you just have to describe or type your response in the chat box or your paper. What's the difference between transverse and longitudinal waves? Okay, so here it is.
Longitudinal waves are also referred to as compression waves. In a transverse wave, the disturbance that makes up the wave is perpendicular to the direction in which the wave travels.
All right, seems pretty...
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels.
Okay.
Longitudinal waves are also referred to as compression waves.
So that's...
In a transverse wave, the disturbance that makes up the wave is perpendicular to the direction in which the wave travels.
Let me go back to the last slide, but that is your two types of waves. So now on your student project, you guys will have to demonstrate that you are familiar and know these two types of waves, which I will talk in detail on the next slide. All right, you guys got that? Okay, cool. So what's the difference between the two? So let's start first with the transverse waves. So when you say transverse waves, the waves move the medium at right angle. So right angle, okay, to the direction the waves are traveling. So transverse means across. So that's why in the ocean, that is your transverse waves. And as the transverse wave moves in one direction, the particle of the medium move perpendicular. So just look at this diagram. So the direction of the wave is going to the right, and then the direction of the medium is up and down, up and down. So that is the wave. So the medium, for example, your water. So the water moves up and down in the ocean, right? As it creates a wave in the direction of the waves going towards the shore. So I'm sure Dean is dreaming about his surfboard today. And I hope you can still, I don't know if you guys can. Can you still surf? I saw the bioluminescence in Carlsbad. It's pretty nice. So there are parts of your wave. So on your project, you should also be able to represent these parts of the wave. So for the transverse waves, you have the crest, which is the highest point of the wave, so at the top. And then the opposite of that, which is at the bottom, is your trough. It's the lowest point. So it means there's least amount of disturbance to the medium. In this case, if we're thinking about water, the lowest point of your water wave is the trough. The highest point is your crest. Okay, and then of course the flat line, when it starts to flat, then that is called your rest position. So it shows no disturbance if it is at the rest position. Okay, so what you can do, you just have to just write down the parts of your waves. So again, let's summarize. The top is your crest, You can just label it. You can just draw it on your paper just so you can remember later on. Crest is the top part of your wave. Trough is the lowest. And then the rest position is the flat point when there's no disturbance at all. If there's no waves in the ocean, then there's nothing. Okay? All right? Are we good? Crest, trough, and rest position. All right. Let's proceed. Second type of mechanical wave is your longitudinal wave. So this is when the medium moves parallel to the direction of the waves that's traveling. So an example is if you throw your slinky away from you, it creates this parallel movement. And the medium moves back and forth, same direction as the wave is traveling. Now, it kind of creates this, what you call compression and spreading apart of the spring. So if you throw a slinky away from you towards a parallel direction, then it creates longitudinal waves. So again, longitudinal waves, parallel movement. And the movement, we describe it as back and forth. It is the same direction as the wave is moving. Okay, so you can draw a coil, a spring, so that is your, and then it's moving back and forth. That is called longitudinal wave. Now, there are two parts of your longitudinal waves, which is the compression and rarefaction. So when the particles of the waves are together in a longitudinal wave, it's called compression. So if you look at the coils in this diagram where they're nearest to each other, you call that compression right here. And if they're far apart, you call that rarefaction. So that is the two parts of your longitudinal waves. Okay, all right. So again, compression, particles close, rarefaction, spread out. Some properties of waves that we need to take a look at, and this normally measures the energy or the amount of energy our waves possess. Let's start with amplitude. So amplitude is simply the energy of the waves, okay? And if you look at our diagram here, the height of your crest from the rest position all the way up is your amplitude. So it's kind of like how strong is that the water's creating that wave. The higher it is, of course, the higher or the more energy your wave is. So in the beach, if there's higher waves, that means there's greater amount of energy that your medium, which is your water, possess. And you can measure that energy in terms of the amplitude. Okay, now that is for a transverse wave. Now for your longitudinal waves, it is a measure of how compressed or rarefied the medium. So the wider your rarefaction is, the more energy is your amplitude, or the amplitude is greater. And if it's compressed, then the amplitude is less. So that's the difference between the two. Okay, so let's summarize one more time. Amplitude has to do with the energy of the waves. Okay, the higher your amplitude is, the greater the energy in your transverse wave. Same is true with your longitudinal waves. The longer your rarefaction is, the farther away the particles are, okay, the greater your amplitude or energy. And if they're near to each other, the less energy of the waves in your longitude. Okay, so that's amplitude. Wavelength for another property. Wavelength is just the distance from one crest to another. So it means that if one wave is created, then the distance, their distance from each other, that's crest to crest, which is the highest point to another highest point, or the trough to trough, that's measuring the wavelength or length of your wave. So how far apart are they from each other? If the waves are too near to each other, probably the energy is great. If they're slowly, the wavelength might be lower. Okay, so that is wavelength. So the distance from crest to crest, trough to trough, or if you're talking about longitudinal waves, the length of the compression to the next compression that's happening, that is your wavelength. Now, frequency, if you look at this animation right here, it is the number of complete waves. So it means at a certain period of time. So how fast does the new wave starts happening is frequency. Okay, and usually we measure that in terms of hertz. And we've heard hertz. Have you heard the word hertz? HZ. Yeah, where aside from a rental car, in a band, in a sound, that's correct. So hertz is how often a new wave or a wave happens at a certain period of time. So per second, so one vibration per second is 1 hertz. So this is your frequency. Okay? All right. Now we're towards the last 2 slides. So in our problem set that I'll post in the discussion, I think it just posted right now, you guys will calculate the speed wave or the wave of your speed, the frequency of your waves, and your wavelength. How to find each. So, okay, Daniela, later on, in order for you to be able to answer the problem set, yes, it will be posted so you have your reference. All right? So again, if you're looking for speed, wavelength times frequency. If you're looking for frequency, it's speed divided by wavelength. And of course, if you're looking for wavelength, you divide speed divided by frequency. And the speed is always meters per second, just like what we had last time when we're talking about force, mass, and acceleration. All right, so let's take a look at this problem. So in your discussion post today, you're going to solve just like this one, but I just need your solution and answer. So a wave on a lake has a wavelength of 0.5 meters. So the distance of one wavelength to another is about 0.5 and a frequency of 2 hertz. So it means it's 2 vibrations per second is this wave in the lake that's happening. So to find it, we simply, speed is missing, therefore we multiply wavelength and frequency. So 0.5 times 2 is 1 meter per second. So that's the speed of the wave found on this lake. So that is an example of the speed problem that you guys will answer. There's only 3 questions of the problem set today that I will post just for you guys to practice how to calculate them. Okay, so please make sure before we get out of here, we're gonna do Quizlet live. Describe how matter and energy interact when waves are generated. So I hope you were able to do that in your project. Second, you're gonna make sure that you know the difference between the 2 types of mechanical waves, which is your transverse and longitudinal. And lastly, the parts of your waves. So you're going to answer that. It's not due until Wednesday, which is your problem set. So in the meantime, let's just review. I'm going to use Quizlet for you to kind of like look back on what we discussed today. And you're going to go to Quizlet.live. And the code is going to be 932922. Really, Adriana? Woo! All right. So pretty much the questions is just from the presentation. We talked about amplitude, frequency, transverse wave, wavelength, waves, and so on. All right. Congratulations, Adriana. Just to conclude what we have, so today you guys will do your problem set. All right. It's going to be in Google Classroom. The PowerPoint or the slide presentation is also attached in there so you can solve your problem. And then I guess that is it because I have a series to watch in Netflix later on. All right, so if you guys are ready to go, please show your way out And thank you guys for coming in today. I appreciate that. And I'll see you next week. All right. If you have any questions, please send me a message. Have a great day, you guys. Thank you. This is it. Week 3 is done. I'm sorry we missed you in our live session today. So I just want to make sure that you guys are aware of what's happening this week. You guys will be working on your Waves student project, and the instructions are posted in Google Classroom. Please make sure that you follow your schedule this week. That's the only big assignment that you have, including the quizzes on Friday. So here's the schedule. You can see behind me. And hopefully we'll see you next week. Have a great day. Bye.